This is R.D. Sharma solution class 12. Chapter 12 higher order derivatives exercise is 12.1. If x is equal to 4z square plus 5, y is 6z square plus 7z plus 3. And this is a parametric form, that means you don't have x on the right hand side. So d2y by dx2, x is given as 4z square plus 5 and y is 6z square plus 7z plus 3. So let us differentiate it. Dx by dz will do. Now just assume that we are differentiating with respect to x and z here is x. So this will be 4z square will be 2z. So 8z it will be plus 0. It's not plus 5, 0. I'll just change it. dy by dz is, again z square is 2z, 6 into 2z is 12z. Now here you have 7 and then 3 will be 0. This is going to be 0. So you have 8z and 12z plus 7. So this is dx by dz and dy by dz. Now we need dy by dx. That is y1 or y dash. So dy by dx can be computed by dividing dy by dz and dx by dz. Okay, dx by dz divided by dy by dz is nothing but dy by dx. So 12z plus 7 divided by 8z. So we have to differentiate it again. So those who want to do by themselves, there is just a reference I have given, and those who want to continue, let us see. We have to differentiate it once more, and the differentiation can be done using the quotient rule. It can be done using the product rule also. So 8z square, I am doing it with quotient rule. So 8z square is 64z square. 8z will remain like this. Differentiation of 12z plus 7 will happen. This is 0. 12z is 12. So 12 will remain here minus. So we have this 12z plus 7 and differentiation of 8z is going to be 8. So just write 8 here. So 12 into 8 is nothing but 96 minus 8. This is again 96z. 8 into 12 it is, I have written 2 I guess, it is 12. So this is minus 56. One more thing is there. Tell me what is remaining. When you are differentiating dy by dx and there is no x, so you have to write dz by dx also. And what is dz by dx? It is the reciprocal of 8z. That is dx by dz is 8z. And you have to introduce dz by dx because you are not differentiating with respect to z. You are differentiating with respect to x. So then yz will be a variable. Now I have divided this 8z multiplied. So the numerator will be negative 56. Denominator will be 64 into 8 into z square into z cube. We have minus 7 divided by 64z cube. So this is the answer. Those who are doing by themselves, this is the answer. If y is equal to log 1 plus cos x, we have to differentiate it thrice. dy by dx, d2y by dx2 and d3y by dx3. Let's see what we get. So there is one point where how this second part of the content which we have to prove, from where you will get it, that is the only discussion. Y is log 1 plus cos x dy by dx. So this will be anything with log comes down, that is to the denominator. So 1 by 1 plus cos x, differentiation of 1 plus cos x is going to be what? Differentiation 1 is 0, cos x is minus sin x, so you can write minus sin x here. This is dy by dx. Now d2y by dx2. So this in the denominator 1 plus cos x whole square, I am doing it using the quotient rule. 1 plus cos x whole square. Then we have 1 plus cos x here. Differentiation of minus sin x will be minus, I am writing here, sin x will be cos x. Now subtraction. Now minus sin x will be like this only. Differentiation of 1 plus cos x is going to be 1 will be 0, cos x will be minus sin x. So it will be negative sin x again. So let us multiply them properly. Numerator we have, just assume that we are multiplying 1 plus cos x by minus cos x. So minus cos x and then minus, this is minus cos square x. What do you get here? Negative cancels. You have a negative, sin and sin in sin square. In the denominator you will get 1 plus cos x whole square. Now you see, minus cos x minus cos square x minus sin square x, I am writing in short. So I am taking negative outside, it will be cos plus cos square plus sin square. Now cos square plus sin square is equal to 1. This is going to be 1. So 1 plus cos x, negative sign here. So the numerator is nothing but negative 1 plus cos x divided by 1 plus cos x whole square. Okay, you will be tempted to cancel it out. Okay. Minus 1 by cos x, but if you don't cancel it, there will be the dy by dx, d2y by dx2 will directly come, but let us see that we have d2y by dx2. See, this is d2y by dx2. Now we have to do d3y by dx3. So d2y by dx2 is minus 1 by 1 plus cos x. dy by dx is minus sin x by 1 plus cos x. So d3y by dx3 is negative 1 by 1 plus cos x. I am applying the quotient rule. So 1 plus cos x in the denominator with square. 1 plus cos x first, differentiation of negative 1 minus negative 1 into differentiation of 1 plus cos x. That is what we will do. And then the result we'll try to introduce the first derivative and second derivative here. Okay, so I'm differentiating negative 1 by 1 plus cos x as I just suggested. 1 plus cos x whole square in the denominator, 1 plus cos x remain like this. D by dx of minus 1, it is a constant, so it is going to be 0. Minus, now 1, so minus 1 will remain like that. And then we have 1 plus cos x differentiation, 1 is 0, cos x is negative sin x. Cos x is minus sin x. So just write minus sin x here. You write minus sin x. A minus minus become plus. So it will be negative only. 1 plus cos x will be 0 because it is multiplied by 0. Here we have minus sin x divided by 1 plus cos x whole square. Now you see here, we have negative 1 by 1 plus cos x, and this is d2 by dx2. dy by dx is minus sin x by 1 plus cos x. So this I am writing minus sin x by 1 plus cos x whole square as minus sin x divided by 1 plus cos x into 1 plus cos x into 1 by 1 plus cos x. Now I am introducing negative 1 numerator denominator. Why? Because we know negative 1 by 1 plus cos x is d2 by dx2 and minus sin x by 1 plus cos x is dy by dx. So d3 by dx3 is equal to what? So this one is simply your d2 by dx2. So write it here, d2 by dx2. Then we have minus sin x by 1 plus cos x. So what is it? The first thing, that is dy by dx, and you have a negative also, this negative. Now take everything on the left, you will get d3y by dx3 plus dy by dx into d2 by dx2, or the way you have to prove, just write exactly like y is equal to sine log x. We have to prove that x square d2y by dx2 plus x dy by dx plus y equals 0. So this type of question we have already done. To just recall, let us do it again. So we have y equals sine log x. So whatever is there in sine, it is not log sine, it is sine log x. So it will be simply cos. Dy by dx we need, d2y by dx2 also we need. So dy by dx is, this sine is cos. So it will be cos log x. Differentiation of log x is going to be 1 by x. Then d2y by dx2. So this again we are applying the quotient rule here. X square in the denominator, x remain here. Cos log x is minus sine log x, and differentiation of log x is 1 by x. Minus. Now cos log x will remain like that. Differentiation of x is going to be 1 because you have to differentiate x, and dy by dx of x is 1. So now this the first term x gets cancelled. You have negative sine log x minus cos log x minus sine log x minus cos log x and divided by x squared. So this y is sine log x. Now you have a x square with d2y by dx2. So you can directly take x square on the left, or you can do like this, minus sine log x divided by x square minus cos log x by x square, d2y by dx2 is here. Now multiply all of it by x squared. So I am multiplying this, I need this, I will get rid of. Minus sine log x. What is minus sine log x? It's y, so it will be negative y. And then cos log x. What is cos log x? So cos log x from here, if you take x on the left hand side, cos log x is going to be x into dy by dx. So this total is dy by dx here and this x here. Now take it on the left. So x squared d2y by dx2 plus x dy by dx minus y is equal to 0. This is the answer. And how are we going to write it? This is given here. So this is the whole steps you have to follow and write. Y is equal to 3 e to the power 2x plus 2 e to the power 3x. We have to prove that d2y by dx2 minus 5 dy by dx plus 6y equals 0. So this question you can do by yourself. It's quite easy. But let us complete it by solving. Y is equal to e raised 2x plus 2 e raised 3x. So dy by dx is 3. e 2x is e raised 2x. Differentiation of 2x is 2. Then 2 e raised 3x. Differentiation of 3x is 3. So you get 6 e 2x plus 6 e raised 3x. This is your dy by dx. So now we have to arrange it such that we get dy by dx and dy with d2y by dx2. So for that we have to find out d2y by dx2. So 6 e raised 2x, 2x is again 2 plus 6 e raised 3x is e raised 3x, 3x is 3. So we have this d2y by dx2 as 12 e raised 2x plus 18 e raised 3x. Now as I said, we need 5 and 6. So we have, see, 30 e raised 2x. If you write 12 as 30 minus 18, so 12 e raised 2x can be written like that, and 18 e raised 3x can be written as like this, 30 e raised 3x minus 12 e raised 3x. So this 30 you can combine together, 30 e raised 2x plus e raised 3x. You can combine them. I mean, the 30 terms can combine. And what about this e raised 2x and e raised 3x? It can be written as negative. 18 e raised 2x, this will be plus 12 e raised 3x. So let me just make it as plus in a short while. Now I'm taking 5 outside from here. You will get 6 e raised 2x plus 6 is e raised 3x. I'm taking 6 from here. So 6 is 18, 3 e raised 2x, and this is plus, as I said. It will be to erase 3x. Now this is nothing but what? We already done that. It is dy by dx. So 5 dy by dx minus 6. What is this? This is the original thing. Y minus 6y. So d2y by dx2 is this. You bring everything on the left hand side. d2y by dx2 minus 5 dy by dx plus 6y is equal to 0. This is your final answer. Y is equal to cot inverse x square. We have to prove that y2 x square plus 1 whole square plus 2x x square plus 1 y1 equals 2. So for reference, because this kind of question we have already done, I guess. So this is the reference for you. I may be doing in a different way. Maybe sometimes it matches with the solution. Sometimes it doesn't. So y is equal to cot inverse x whole square dy by dx is equal to, so twice come in front, cot inverse x, then differentiation of cot inverse x is negative 1 by 1 plus x square. So cot inverse x differentiation is negative 1 by 1 plus x square. So what do you get? Minus 2 cot inverse x divided by 1 plus x square. This is your y1 you can call as dy by dx. Now y2, that is d2y by dx2, we are going to find out. So 1 plus x square whole square, 1 plus x square here, differentiation of minus 2 cot inverse x. So minus 2 will remain like that, and cot inverse x differentiation is negative 1 by 1 plus x square. So minus 2 will come here. Cot inverse x differentiation is minus 1 by 1 plus x square. Then you have minus here. Then we have same thing here, minus 2 cot inverse x divided by 1 plus x square, and differentiation of 1 plus x square is 2x. Okay. So this 1 plus x square gets cancelled, minus plus, so 2. This also minus will become plus. 2 into 2 is, you can write as 4x cot inverse x. So you can write it as 2x into 2 cot inverse x. Okay. 1 plus x square whole square in the denominator. So 1 plus x square whole square here. 1 plus x square whole square. You can write it as 1 plus x square into 1 plus x square. So y2 is this. So 2 by 1 plus x square whole square. What is it? So let us remove this and bring it to the left hand side. 1 plus x square whole square. 2 will remain like that. Don't worry about that. 2x, 2 cot inverse x. What is this? In the question it is saying, do we have anything like this? Yes, we have it. Minus 2 cot inverse x into 1 divided by 1 plus x square. So what we'll do, we'll multiply a numerator and denominator by 1 plus x square. So like this. So when you introduce this numerator denominator, one of the content we got as y1, but it is negative. So I am multiplying negative 1 numerator denominator, and this negative 2 cot inverse x divided by 1 plus x square is what? Is y1. So you have 2 plus y1. 2x is already there. 2x already, and the shape I made inside that, it was y1. There is one more thing. 1 plus x square we also introduced. So 1 plus x square is also there, and you have 1 plus x square whole square into y2 and bring everything on the left hand side. 1 plus x square into x whole square into y2 plus 2x y1, 1 plus x square, and this 2 you can keep it on the right. This will be on the right. Okay, this is your solution. So this question, I'll just give you a reference and we will do it entirely. Okay, the only thing which you need to know is the differentiation of cosec inverse x. So y is equal to cosec inverse x dy by dx is equal to negative 1 divided by x square minus 1 in the root. This you need to remember. d2y by dx2 is the denominator, just square it. This will be x square, under root x square minus 1 will be x square minus 1 only. Then this x into under root x square minus 1 goes here. Differentiation of negative 1 is going to be 0. So let me just write 0. Constant differentiation is always 0. Then you have minus differentiating this x under root x square minus 1 will remain like that. So d by dx of x under root x square minus 1 we have to do. Let us do it now. So this x, I am using the product rule, x divide dx of x of under root x square minus 1 plus under root x square minus 1 divide dx of x is 1. So I am doing it using the product rule. X plus under root x square minus 1 divide dx of x is 1. So under root x square minus 1 can be written as x square minus 1 to the power half. Differentiation will be half x square minus 1 to the power half minus 1. This is half x square minus 1 to the power half minus 1 is negative 1, negative half, and differentiation of x square minus 1 will be 2x, 2 gets cancelled, x will be in the numerator. This x square minus 1 to the power minus half will go in the denominator, it will have a root. So this under root x square minus 1 will become x by under root x square minus 1. So we already have under root x square minus 1. If you want to resolve, you can resolve it here. So let us resolve it here. Minus, first term is already 0. Minus into minus 1 is plus. So only the numerator will be d by dx of this only. So just do it. So we have this is x square by under root x square minus 1. X square by under root x square minus 1 you will get. And then in the denominator, so this x square into 1, that is x square only, and this under root x square minus 1, under root x square minus 1 will be x square minus 1. Oh, there is a slight thing, x, this is not x, this is x square. I'll just change it. Okay, so you have x square. So your x square plus x square minus 1, you will get 2x square minus 1, and the denominator you have under root x square minus 1. So this can be written as 2x square minus 1 divided by x square is already there, x square minus 1 is also there, and under root x square minus 1 will come like this, under root x square minus 1 d2y by dx2. Now you see this x square minus 1 into x can be taken on the left hand side. So first we'll take x square minus 1 on the left. This I am separating these two to x square minus 1 term and minus 1 terms with the denominator. So this has been separated, and as I said, we have d2y by dx2, x square minus 1 is in the denominator on the right hand side. Multiply everything, all of it by x square minus 1. So x square minus 1 will come here. Now just delete this. This is x square you can cancel, but no need to, because we will just keep the x, because x by under root x square minus 1 is ultimately what we need. So can we make this negative 1 by x under root x square minus 1? That is what we want. So this is 2 by under root x square minus 1. So under root x square minus 1, we have introducing x. So negative x and negative x in the numerator, denominator I am myself introducing, because one of the term is going to be dy by dx. Rest of the term will be as in the question. Alright. So this is dy by dx, this portion which I made. So this is minus x divided by minus 1 is minus x, so minus 2x, and this whole content is going to be your dy by dx. Then your minus 1 by x square under root x square minus 1. So minus we already have. So we have this, x square is there, so you can just write it as x into x. So 1 by x under root x square minus 1 with a negative. There is a negative sign in front. This is going to be dy by dx, and we have 1 by x also. So as I said, minus is also included, so there will be a plus sign in between, right? Now x square minus 1 here, d2y by dx2. So we have an x extra in the denominator of the second term of the right hand side. So what we'll do, we'll multiply everything by x, this x square, this goes. Now bringing everything on the left hand side, x square minus 1 d2y by dx2, and then we have this dy by dx. So it will be dy by dx on one side, and this 1 minus 2x square, when it goes on the left hand side, it will be 2x square minus 1. So you can have, so this minus 2x square plus 1. So we have this d2x square minus 1 dy by dx equals 0. This is what you have to prove. This question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.